Algebra 2, Lesson 107, Numbers, Numerals, and Value and Number Word Problems. So, we're going to go straight into the examples of number word problems. All the review on numbers and numerals is just an analysis of 10 two-digit numbers and what their two digits mean. For example, here we've got the number 27. The number 27 is made up of the numerals 2 and the numeral 7. In this case, when we read the number, we recognize that the numeral 2 has a value of 20 and the number 7 has a value of 7. Right? That may not seem like a lot, but it makes a lot of play when it comes to solving the problems. And then here in the number 11, the first one has a value of 10 because it's in the tens place. The second one has a value of 1 because it's in the ones place, or what they're referring to as the units place. And that's going to help us solve these equations. It'll help us effectively rewrite equations. To give you a quick example of this, I'll take the number 42. Right? So what I could say is I could say the number 42 is equal to 10 times the number 4 plus 2. Or you could say 1 times the number 2. All right, so what we're doing is we're assigning place value here. We know that the number 4 in this number has a value of 40. If I do 10 times 4, that's 40. And then the 2 has a value of 2, or 2 ones, and 1 times 2 is 2. So this would be 42 plus, okay. So now the way we do that as an unknown, or as a variable, is they call it tens digit and the units digit. So if I wanted to represent 42 in algebraic terms, I could say the tens digit and the units digit, and then that is going to equal, or the number is going to equal 10 times the tens digit plus 1 times the units digit. Now you may have realized 1 times the units digit is kind of lame, so there's a faster way to write this. If you want to write an unknown number, you could say it is equal to 10 times the tens digit plus the units digit. All right, so that's essentially the same thing, but this one's just a little bit more cleaned up and easier to read. So 10t plus u, 10 being value of 10, u being value of 1. And so this idea is what we're going to be using to solve these problems. Now let's get straight to the examples. Well, straight to the examples. We've already been 2.5 minutes in. Let's finally get to the examples. We've been looking at that one. Let's go to 107.2. So, this seems kind of blurry. All right, so in 107.2, they told me the sum of the digits of a two-digit counting number was 9. So what they mean by that is, if I were to take my number 42, for example, my example number, the sum of the digits in the two-digit counting number of 42 would be 6. So what they're saying is 4 plus 2 equals 6. In this problem, we don't know what the number is, and they're saying that the numbers add up to 9. Okay? So when the digits were reversed, the new number was 45 less than the original number. What was the original number? So let's focus on that first equation. The sum of the two digits of a two-digit counting number was 9. Really easy way for me to write that. I can just put the tens digit plus the units digit equals 9. All right? That equation is very, very simple. Now let's look at the second half. They say when the digits were reversed, the new number was 45 less than the original number. Okay, so we have to figure out how to write the number with the digits reversed, and then we have to write the new number 45 less than the original number. So if the digits are reversed, all we have to do is take this equation that we've got up here, 10t plus u, for our number, and we reverse the t and the u. Okay. So for example, if 42 is reversed, it would be 24. All we'd have to do is replace the t, or the 4 number, with u, the 2 number. So that's what we're going to do here. So digits reversed means 10u plus t. And they say when the digits were reversed, the new number was 45 less than the original number. So that's going to equal the original number, which we know is 10t plus u, and then 45 less than that. So that minus 45. So now I've got two systems of equations with two unknowns, and I can start substituting, eliminating, and solving. But before I start doing any of that, I want to rewrite this bottom equation and clean it up because it's a little muddled. So we'll go ahead and move the t and the u to the other side. So if I subtract 10t, here that cancels, and then I end up, and then we'll go ahead and subtract u at the same time. That cancels as well, so 10 minus u gives me 9u plus, oh whoops, not plus, minus 9t equals negative 45. All right, so that's my first equation, or well, that's my second equation, and then I've got my first equation down here, which I can bring down here, which is, let's see here, u plus t equals 9. I know I reversed the u and the t. The reason why I did that is because I'm about to use elimination. You could use substitution to solve this as well. I just see an opportunity to use elimination, so I'm going to. All right. So here I see negative t, positive t. I can multiply this bottom equation by 9, and then that will give me opposite terms. So this would become 9u. This becomes positive 9t, and that is going to equal 81. So that equation is gone, and then I can eliminate here. So negative 45 plus 81 is going to add up to, let's see here, 81 minus 5 is 76. 76 minus 40 is 36. So that is going to equal 36. Let's go ahead and switch to a different color. So 81 minus 45 is 36. Negative 9t and positive 9t cancel, and then 9u plus 9u equals 18u. Last step, I divide each side by 18. 18 goes into 36 exactly 2 times, so I know that the units number is equal to 2. Now if I take that and I plug it back into this, then I have t plus 2 equals 9. So then I subtract 2 from each side, and then t equals 7. So u is equal to 2, t is equal to 7. Now if I take the tens unit and the ones unit and I put them together, the original number is 72. And that is our final answer. That's it for this problem. If you guys have any questions, let me know on Moodle. Also, don't forget these 2 equations here, 10t plus u, and then 10u plus t. So this is the number reversed. Yeah, if you guys have any questions, let me know on Moodle, and I will see you in class.